everyone, for the last video we have talked about question number 4. For this video we're going to talk about question number 5 part A, that is write the algorithm for Ranji-Kutta order 4 method. Now what exactly is Ranji-Kutta method? Uh, Ranji-Kutta methods are the family of iterative methods that are used for solving ordinary differential equation in the setting of initial value problems where we are given a differential equation. The significance of those initial value problems is that they are given a sort of initial point and the slope of the function at that point, and hence we have to figure out where is the next point. And so the algorithm at a high level for Ranji-Kutta method would be taken one step along the slope, picking up the next point, that is y naught, from that step, and then we would evaluate the slope at that new point y naught and step along the new slope. So the most frequently used, the most frequently in practice is the fourth order Ranji-Kutta method. So as you can see here, the form of fourth order Ranji-Kutta method is yi plus 1 is equals to yi plus 1 by 6 k1 plus 2k2 plus 2k3 plus 2k4, which is multiplied by h. Now how to find these constants? We have another set of formulas to generate them. We firstly have to take the function given to us, and then after evaluating all the value of k1, we have to put the value of k1 in the k2 equation and generate the k2, and subsequently we have to go for k3 and k4 as always. So on to the algorithm. Firstly we have to start and define the function fxy. Okay, so to define a function we have to firstly read them. So run a loop for that, and after running the loop you would get the value of x with the subsequent value of y, and after doing that read the value of initial condition, that is x naught and y naught, number of steps, how many x are given to you, and a calculation point of xn. After calculating that, we have to calculate the steps, right? That is h, that is to be multiplied in the given form of fourth order. And so how to do that? We have to get the value of xn minus x0 by n. After that we have to set the value into I is equals to 0. So in the sixth step you have to run again a loop where you have to firstly calculate the value of k1, however the fourth order of the formulas guide you. And so in the same way k1 would be generated, k2 would be generated, all the formulas that we have learned in the last slide would be kept in the loop, and after that while as you can see there is a while I less than n, while doing this we would display the value of yn as a result, and this would end up with our algorithm. Hello everyone, for the last video we have done the part A. For this video we're going to do the question number 5 part B, that is apply a predictor corrector method to solve the given equation. Now to do that we should firstly know all the formula that is given here, which is the modified Euler's formula, as it is written here as yp n plus 2 is equals to yn plus 2 hf yx1 xn plus 1 and yn plus 1. And after as you can see here, that this is actually our Euler's modified formula. And after doing that, by Yun's method we would calculate the value of k1. Now k1 is the same as our Ranji-Kutta one, it is a different one, and we would generate the first value same like Ranji-Kutta. We would firstly take the value of fx1, fxi, and y1, yi. Then put that k1 value and the k2 value to calculate the value of k2. Now we would take the mean of both of them. I mean the k1 and k2 value, we would take the mean of it and put it in the value as k is equals to k1 plus k2 by 2. And then we have another equation here, which is the Hens method equation, which is yi plus 1 is equals to y1 plus kh. We would put the value of h here. And how to get that step size? You just have to take the first one, take the first x naught, and the last one, that is the xn minus, take the difference of it and just divide it by the number of variables, that is n, and you would get the step size, that is h. And after doing that, multiply it by the k that we have got from here and just add it to y1, and hence we would get the value of y is equals to y 0.1 as 0.9975. Now on to the now to the value for y when x is 0.2. This was actually when x was 0.1, and now we have to take out the value for x is equals to 0.2. Again we would take the same method. I mean we have the earlier method of Euler's formula, that is y2 plus 2hf, which is x 0.1, y 0.1, and we would put the value of both. The y2 is actually the previous value that we have got. So we know the value of when x was 0, the value of y was 1, and so we have taken that one value here as a previous value of y, then 2 that you can see here, h as the step size, and function that we have here, that is dy by dx is equals to minus xy. We just put the value of the value that I have generated earlier to get the value for y is equal y 0 when x is 0.2, the value of y is 0.98005, and which this is just predicted one. Again we would predict it to get a more accurate one. This is not more accurate. This to get more accurate, we would solve another way, which is when we would get y 0.2 is equals to y 0.1 plus h by 2 f of the whole f of x 0.1 y 0.1 plus x of, like we have got the we would add the values that we have got till now, which was x 0.1 and y 0.1. Then again we got the value for x 0.2 and y 0.2, and that's how we just add all the values that we have got and get a more accurate for the result of 0.2. Now if you want more accurate than this value, you just have to go for another iteration. As we go along the iteration, the accuracy will increase, and so with this the part ends.